So the big O operations that I'm showing you, it can depend on the linked list data structure that you're given. It may not have a front or a rear pointer or something like that. It might be something different. So these numbers might be slightly off, but bear with me here. So if we're comparing a linked list with an array, we have our index of function. Now notice the array, it takes about one because you're given the location and go from there. But here, remember with the linked list, if we had an index of function, we would have to hop to that location to get access to it, and then voila, then we finally get there. So while it may not be n, but it's going to be, well, n divided by 2 is still, the highest term is still n. So inserting at the front, here's a nice part. That really only takes an operation of 1, but think about it for an array. If I wanted an established array of numbers, I want to add to the front of the array, I'd have to push everybody back. And the same thing for deleting from the front. I'd have to push everybody forward in an array. A linked list, it doesn't care. Just the engine gets replaced with something else, and we're thinking about a train. Inserting in the middle is going to be somewhere O of n. And it's going to be the same thing for an array because, again, it's going to push everybody back or push everybody forward if we're deleting from the middle as well. Inserting from the rear is where things differ from my version to maybe somebody else's version that you see online or your instructor. But because I have a rear pointer, it goes ahead and does it really in O of 1 because it's already set up. Create a new node, insert a couple items, boom, it's done. That may not always be the case for some of the setups that you may see. And then for the array, it's also debatable too, is that what if you ran out of space in the array? So this could be n because we have to copy more space for it, or if it happens to have space, so we know the end of it, we go ahead and put a 1 there for now. But see, that's even debatable too. So this is just a preliminary comparison between the two.